Hello everyone, hope you are doing well. In this video we are going to talk about why absolute value of x is not differentiable at x equal to 0. So let's get started. We know that a function f is said to be differentiable at a point x0 if limit h tends to 0, function of x0 plus h minus function of x0 divided by h exists. So a function is said to be differentiable at a point x0 if this limit exists. The function we are talking about is y equal absolute value of x. This absolute value function, we can write this as piecewise function like this. It's equal to x when x is greater than or equal to 0 and minus x when x is less than 0. You can also see it graphically if we want to. The graph of absolute value of x looks something like this. The graph of absolute value of x looks something like this, where you can see that at x equal to 0 we have a corner point, sharp corner point, so we can say that it is not differentiable at x equal to 0, because when we have a sharp corner point like this, the right derivative and the left derivative are not equal. If we want to say it mathematically, then we have to calculate that limit that we talked about earlier. So let's find the limit of this. Our function was f of x equal absolute value of x. So when we calculate the limit, f prime of x naught equal limit h tends to 0 function of x naught plus h minus function of x naught divided by h. The x naught is 0 because we are checking the differentiability at point 0, so x naught is 0 here. Now if we calculate it, limit h tends to 0 function of 0 plus h minus function of 0 divided by h. And this is equal to limit h tends to 0 function of h minus function of 0 divided by h equal limit h tends to 0, and this function of h is basically function of x was equal to absolute value of x, so function of h will be absolute value of h, and similarly function of 0 will be absolute value of 0, that is 0. So we get absolute value of h minus 0 divided by h, that is limit h tends to 0, absolute value of h divided by h. Now we calculate the left derivative and the right derivative, because we have to calculate the one-sided limit here, because we know if the one-sided limits are equal, then the two-sided limit exists, otherwise it is not. So if we calculate the right derivative first, limit s tends to 0 plus, that means it is coming from the positive direction to the point 0, then so if we calculate this on the positive direction, h by h, this is equal to limit h tends to 0 plus, and the absolute value of h value will be h divided by h, and this is h because we are coming from the positive direction to the point x equal to 0. We can see that in our piecewise functions that we discussed about earlier, that when x greater than 0, the value of absolute value of x is equal to x. When x less than 0, it was minus x. That means we are coming from the negative direction to the point x equal to 0, and for this we are coming from the positive direction to the point x equal to 0. So this will be equal to limit h tends to 0 plus 1, that means we get 1. Similarly, if we calculate the left derivative, this limit h tends to 0 minus absolute value of h divided by h, we get limit h tends to 0 minus, and this will be equal to minus h because we are coming from the negative direction to the point x equal to 0, and this is limit h tends to 0 minus 1, which gives us the value minus 1. Here we can see that our right derivative is positive 1 and the left derivative is minus 1. So we get two different one-sided limit here, and the limit of this one-sided limits are not equal. One is positive 1 and the other one is negative 1. And we know that when the one-sided limits are not equal, then the two-sided limit does not exist. So at x equal to 0, the function absolute value of x is not differentiable. You can say that since the one-sided limit are not equal. So we write this, the function of x equal to absolute value of x is not differentiable at x equal 0, but it is differentiable in other points, but only in x equal to 0 it is not differentiable. At prime x will be 1 when x greater than 0 and minus 1 when x less than 0. We can write this from our piecewise functions that we had. We can see that this is our function f of x, and this is equal to x and minus x when x less than 0. If we differentiate it with respect to x, we get 1 when x greater than 0 and minus 1 when x less than 0, and at x equal to 0 the function is not differentiable. So the derivative here is 1 and minus 1 for two directions. If we want to see it graphically here like this, this is 1 and this is minus 1, and we made an open circle here. This is because the function is not differentiable at x equal to 0. That's why we made this open circle. And the derivative, when we are coming from the positive direction towards the point x equal to 0, we get 1 and minus 1 when we are coming from the negative direction. So that's all for today. Thank you for watching, and please don't forget to subscribe. Stay tuned for more videos like this. Thank you.